Hello, everyone. Welcome. My name's Neil Creek. I'm from Mount Bennett Observatory, and tonight I'm going to do a live astrophotography session streaming via our website, our Facebook page. I've got everything set up outside, and I just need to go through and do the focusing setup routine before I can get some images. That may require me to pop in or out a little bit. I didn't get quite everything done for the setup before the stream started, but it might be interesting to have a look at that as well. I have got things set up now with the stream mirroring the laptop that I have outside, and that will also allow me to show you the telescope itself set up out there. So you'll be able to watch it as it pans around the night sky. In fact, you can see up here, there's a satellite going through the view right now. How cool is that? Actually, I'm going to move this over to the main window for me, so I'm not looking over the side for that. Okay. I am going to be taking questions and comments from folks tonight. If you've got anything you'd like to ask while I'm going through things, or if there's anything you'd like to say, just leave a comment. We've got some of the MBO team helping out tonight as well. Petra's helping me out here in the streaming interface, and we've got Heike and Stuart and some others in the chat, and they will identify themselves with a comment in the Facebook comments as well, just to let you know who they are. So, look, we've got beautiful stars there already behind the telescope. I've done my polar alignments. The telescope's aligned and pointing at the right spot. I just need to focus it correctly now. And when I was doing that initially, it looks like it was in the right spot, but I wasn't getting any visible stars. So let's just troubleshoot this. Shouldn't take me too long to get it sorted. I reckon it might just be in the wrong spot. So let me go back to, let's say, go to 0. Oh, and you might hear a meowing in the background. That's my cat, Arky. He's a little bit hungry. He often is from time to time. Wonderful. I can see we've already got 238 folks who have joined us. That's fantastic. Welcome, all of you. I'm glad that you could join us. Now, that hasn't got it to the right spot. So what I'm going to do, actually, if I go to, I think it's 6,500 is the furthest out position, then I will manually move the focusing knob outside to be at its furthest out position, so that the positions in the focus control and in the actual physical focuser will match up. And we saw the stars just briefly there as it went through the focus point, but I want to make sure that I've got it in the right spot, so that when the computer controls it, it knows it's pointing at the right place. Now, I'm going to do my best to try and keep up with the comments, but with 200 odd of you, I'll probably miss a few, most of them. Any questions that you have, my fellow MBO people, Mount Bennett Observatory people, will do their best to answer them for you if I can't get to them, but I'll pull them from the questions as well when I can. All right, so it looks like it's where it thinks it's at its furthest position out. So I'm going to go out there now, and you'll see me shortly, and I'm going to go adjust the focusing knob here to get the focus to the same position that the computer thinks it is. So I'll be right back. right, it was in the fully in position. So I will disconnect the focuser and then reconnect it, and that should hopefully reset it to 0. Oh no, it kept it at 6200. That's odd. All right, we'll try and go without having to worry about that. We'll just do it and focus manually with the autofocuser and see if that gets us the result we want. While I do that, I'm just going to see if I can see it moving out. Yes, there, you can see it moving out. It looks like the values are inverted from where they should be. 0 should be all the way in and 6200 should be all the way out. So that was why I was having trouble with that. So let me see if there's an option in here to invert it. No. That's all right. I just won't let the computer automatically do a focusing run. I'll focus once manually and I'll leave it there. So let us go in. Oh, this is Arky. He's my hungry, annoying boy. I gave him dinner at 6. He doesn't usually get a supper until 11 o'clock, but he starts bugging me about an hour beforehand. Some of you will already know Arky from past streams. All right, so we don't want to go in, we want to go out because that's the reverse of where it thinks it is. Oh, Arky, he's just unplugged my headphones from the microphone. Thanks, buddy. All right, so yes, tonight we've got the beautiful summer skies. So we've got Orion, we've got Taurus, we've got Canis Major, some of the most beautiful objects and bright stars in the night sky. We've got one special request to do a photo of Betelgeuse, which we can do. But I'm going to start with the crown of the summer night sky, and that is the great nebula in Orion. Everyone can see Arky, and he's commenting. That's wonderful. All right, we'll just rapidly move through focus here and see if we can see the stars popping up. Oh, here we go. They're starting to appear here. So we're getting closer. Thanks, mate. Okay, there we are. We're pretty close there. So at this point, I am going to stop the auto imaging and I'm going to do the auto focus routine, which is there. So this will take a minute. And while that's happening, I'm going to just catch up on comments. Well, some of them. Madeline, that's fantastic that you can see them right through your window. That's brilliant. We're going to be definitely looking at Orion and some of Canis Major tonight. Yes, he is absolutely right on schedule. We do definitely love our Astro Cats at NDO. Quite a number of our members have cats, and one of my friends, Peter, he has Galileo and I think Huygens are his 2 cats, which I think are wonderful names. So Kevin asks, the first technical question of the night, what telescope am I using and camera? So let me bring up an image that I took a little bit earlier this evening after I set up the scope. Good, we've got focus. I'll come back to that shortly. I will share what I'm seeing shortly. I just need to get it on screen first. Okay. As a photographer, I have tens of thousands of photos on my computer. So I have drives within nested drives within folders within nested folders that I've got to get to. So it's also a little bit more of a challenge to do all this while I'm chatting to you. It's a distraction. Okay. Bringing up the photo now. Okay, so this is my setup. I took this just after setting it up earlier this afternoon, or late afternoon. So the telescope here is an 8-inch f4 Newtonian reflecting telescope. It's on a EQ6, an NEQ6 telescope mount, which is a German equatorial mount that will, once I polar aligned it, follows the stars. I have attached to it here a camera, which is an ASI 1600 mono. So that's an astrophotography specific camera. That's all connected through to my laptop via USB, and the laptop is connected via network into power over, Ethernet over power, and that then goes back into my house. I've got a battery here for a couple of devices that I don't have 240-volt power supplies for. And here you can see the camera setup, which is watching the telescope. So if I go back to the other view and we look at this view, I'm clicking up the OBS interface, silly me. This view here, that is the telescope, well, that is the camera that is seeing this view. So now that we've got focus, we can go to a target. So the first target I'm going to go to is good old M42, the Orion Nebula. Now, the image that will pop up here shortly is not one of mine. It's a catalog image. And I use that as a reference for planning the photo. So what I can do now in this catalog image is just draw a box and position that box where I want it to go, where the box represents the field of view of the camera on this telescope. So I position that where I want it to go, and I'm deliberately leaving out this object because I'm going to shoot that separately in a moment. And then I click Create Sequence, and it will then create a target, create a target in my list here that will have the same framing once it's pointed in the right direction as what I told it to. So let's center on that now and watch the telescope move over there. So you can see it moving there. That's so satisfying. All right, while it's moving, I'm going to come back over. I should probably hide the comments after I've answered them, shouldn't I? Okay, are we mainly looking towards Orion? We'll look in the Milky Way in the direction of Orion. There's a few places out there that are interesting, but certainly not for the whole night. There's a lot of stuff out towards the Southern Cross, Eta Carina, that sort of area that is also very interesting. So we'll go there at some point. Okay, so what it's doing now is it is showing, it is taking a photo of where it went to. It thinks it's in the right spot, but it's probably not, because every time I set the telescope, it's sort of slightly moved a bit. So what it does is it takes a photo, looks at the stars in that photo, and then tries to find those stars in a catalog. When it finds them, it says, okay, this is where I'm actually pointing based on the stars that I can see. I'm off by X amount. It then corrects for that and moves the telescope to get into the right spot so that it will get where you need it to be to get the framing that you want. We've got someone joining us from the Gold Coast. Thank you for coming along, Kelly. Oh, I've seen you before. You're on holiday, aren't you, up in the Gold Coast? I'm glad you could still join us. Oh, wow. We have someone from the Astronomical Society of Tasmania here tonight. Wonderful. Thank you for coming along. It's great to see you here. I hope you enjoy the stream. Let's see how we went on that. Okay, so we've moved along and it found it in the first frame, the first plate. So that means that after correction, it is on target. So the initial position was off by 14,000 pixels, but after correction, we're within 35 pixels. So that is perfect, bang on. Now, when I close this, you're going to see in the background the image that it took. Now, the Orion Nebula is so bright that it's going to look impressive even in that preview image, but we're going to do better than that. So there we go. All right, now I'm actually going to close this software. I don't usually use this software when I'm doing live astrophotography. I am going to instead load Stellarium, which I use to find objects and control the telescope. And I'm going to load a second instance of SharpCap. SharpCap is what I'm using to view the black and white camera that's watching the telescope. But I'm also going to load it to watch the color camera. which is in the telescope. So I've got two instances of it running. All right, so cameras, MC, that's color. And there we go. How's that? Look at that color. It's beautiful. So what we've got here is a preview setting for this camera that takes very frequent, like 4 or 5 frames per second. What have we got here? 4 frames per second images of the target. Now, the Orion Nebula is so bright that even 4 seconds with, high gain and other settings to make it look brighter, it's still visible. Oh, I just saw a satellite zip through there too. But when I'm actually doing my imaging, that's not the best settings for it. But I just did this just to confirm that we are pointing in the right spot. And now that I have confirmed that we're pointing in the right spot, I'm going to connect my telescope to Stellarium, which is the control software I'm using, and tell it that we are pointing at Orion. So it's updates the pointing model for Stellarium. But first I need to connect the telescope. All right. And it thinks it's pointing there when I know it's actually pointing here at M42. So what I'm going to do is search for M42. And then I'm going to tell it to sync. So it synchronizes its pointing model with the current object. And you should see that move over here. It should. Current object. Synchronize. Huh. Oh well, I'll come back to that. But for now, we've got it in our view. Oh, it's moved off a bit. All right, let's just move that manually, just because I want to get an image. Oh, I know why it's moved off, because it's not tracking. Not solar, star rate. All right, so let's get this back in center. Although it won't be quite center because it's brightest at the top right as from our current view, and it gets fainter out to here. So there is stuff out here. I might move it a little bit that way. Yeah. All right. So now I'm going to go over to the imaging preset. I have to click load. And what that will do is it will continuously take 15-second exposures. I'll come back to that. And it will stack them. So what that means is it takes a photo after photo after photo of the same object. And then, oh, look at that. How good does that look, even from a single 15-second exposure? But what it'll do is it'll keep taking 15-second exposures and it'll align them together and then blend them so that the noise, the grain, which is random between each photo, gets decreased. You might have been able to see there the noise that was in the first frame halved by the second frame. And the signal, that will be added together. So that's constant in each frame, whereas the noise is random for each frame. And each time you double the number of frames you take, you halve the amount of noise. So the second frame halved the noise that was in the first one. But it won't be until you get to the fourth frame that it halves it again, and then the eighth frame, and so on. So it complained a moment ago about PhD guiding not working. Well, guiding is a tool that lets me follow the stars precisely so that I don't get any movement of the telescope between each shot. It doesn't matter too much for short 15-second exposures, but I'm going to turn it on anyway, just because it helps make things look better and sharper. Okay, don't worry about that for now. Now, what this should do is turn the camera on. There we go. So as you can see, the guide scope is a little bit misaligned from the main scope, but that doesn't matter. It doesn't affect what I'm doing with it. So I select a star, or I let the software select one, but that's too bright. The top's flat. It shouldn't be flat. That's a little bit. How about that one? There we go. Got a nice pointy top, which means it can see the center of the star clearly. And now I'm going to track or guide on that star. So having done that, I am going to actually stop this sequence because I want to start it fresh. And that will then give me the best possible results. So while it is getting a few images for the stack, that actually looks a bit motion blurred, doesn't it? Let me just clear that one and see what the next one comes up. Yeah, that's better. All right, while that's stacking, I'm going to go and check on comments. All right. Thank you, Haley. Yes, greetings from everyone in Melbourne and best for everyone in lockdown. We went through a very long, difficult lockdown in Melbourne. That was when we started up our live streaming for MBO. And it was great to be able to do that for folks. But there's a bunch of people now going into lockdown. I believe Brisbane is in lockdown now for 3 days, fortunately only that long. And we wish you all the best and everywhere else around Australia as well. Pardon me. Okay. All right. Now, I have got Petra helping me in chat, and I just noticed in private chat she sent me a few points that there are particular questions coming up. Petra, what I might get you to do is when you see a question that you think I should answer, I'll just get you to click on it and put it on screen, and I will see that at some point, and I'll then be able to answer it. So thank you for your help with that. Okay, we've got 6 stacked frames now for a total of 90 seconds of exposure. That means that I've got enough data to have a little bit of a play around with that. So what we've got down here is what we call a histogram. And the histogram is a graphical representation of the distribution of the brightness of the pixels in the photo. So on the left, we've got the darkest pixels, and on the right, we've got the brightest. Now, we can set these vertical lines here as being the black point, the white point, and the mid-levels. The white point here, as you can see, is to the left of the peak of the pixels for the stars. So I don't want that. It's going to blow those details out. So I'm just going to drag that to the left of that. The black level, it's looking pretty dark in the corner. So the black level is actually probably pretty good. Yeah, that's too low contrast. Let's drag it a little bit. Oh, gee, it's a bit laggy. I don't want to get it perfectly black, but that's pretty good. Now let's adjust the mid levels to see what we can get. Now it's a choice between the bright center being exposed correctly or the faint outer edges being exposed correctly, because the Orion Nebula is such a bright object in its core that it's easy to lose details in there while you're trying to get the fainter stuff further out. So it's a bit of a juggling act with this one. And often with this object, I'll actually take 2 sets of photos, one exposed for the brighter areas and one exposed for the fainter areas, and then blend them together afterwards. Now that's looking all right, but I think the color is a little bit off. Let's just go with an auto white balance based on star color, see how that looks. No, that's gone too blue. So let's try an auto color from the histogram peaks and see if that's any better. That is better. Not quite as pink as it should be, though. So let's drag up the reds a little bit. Not that much. That looks about right. And let's increase the saturation. There we go. That's looking good. Now, my camera just dropped out for a second there. I'm running a digital SLR as a webcam. And the camera doesn't stay on for more than half an hour at a time. So every half hour, it'll just turn off for a second and back on again. All right, let's take out a little bit of yellow. Oh, sorry, we need to increase the blue to do that. And maybe play with the green a bit. Yeah, that's starting to look pretty good. All right, so we can now play with these levels again a little. And that's starting to look pretty nice. So this object is a really, look, I wouldn't say an easy one to shoot, but you can get great results very quickly because it's so bright. But it's a challenging one because if you want to get both the bright stuff and the faint stuff looking good, it's a real juggling act. All right, let's move this out of the way a little bit so we can see that a bit larger. And isn't that glorious? I love shooting this object. Every summer I come back to it just because it's so beautiful. All right. Let's catch up on comments. Okay, MBO. Okay, that was not meant to come up, perhaps. Let's see. I've got this one from Sam. Oh, looks like we both clicked on the same time, Petra. Okay, Sam, how long did it take you to learn all of this software, etc.? So I've been doing photography for about 15 years. I've been doing astrophotography for about 8 to 5 years, depending on when you sort of said that I started. My very early stuff was done with digital SLR and tripod, and the early days of that was really challenging because the SLRs weren't quite up to it. The first one I started doing it with the Sigma SD10, and that was terrible. The Canon 350D was barely good enough to get me started, but once I got the 5D Mark II, that was a great camera. That was good enough to do really good stuff, really good photos. Telescope stuff, however, I've been doing this for about 4 years now. And it is a steep learning curve. There is a lot to learn in the hardware and the software and the processing techniques and all the different bits and pieces that go into making a great image. So, yeah, it's been a lot of work, but it's fun at the same time. It's one of those things that I enjoy the challenge, and the results you can see for themselves. They speak for themselves. You get really rewarded for the work that you put into it. So, yeah, I would say about 4 years to get to the point where I can do stuff like you're seeing here. Okay, Scott asks, what are you using to control the telescope with Stellarium hardware-wise? So let us go back to the photo of the setup. There we go. So on the other side of the telescope here, there is a mount point for the hand controller. The hand controller isn't used for this. So I have a cable that does the same thing, except it connects to a USB cable. And that USB cable then goes into a USB hub, which is mounted on the telescope, and that then goes back to the laptop's USB. That's a really handy cable. It replaces the need for the hand controller, but it's impossible without using the right software, because the software is what mimics the hand controller. It impersonates it and takes over the control of the telescope that way. Fortunately, several years back, some very thoughtful and smart people got together and created a standard called ASCOM. And ASCOM is a software standard that lets all different types of astronomical equipment talk to the computer in the same language. So it acts as sort of like a translator between all the different bits and pieces of equipment. So the cameras, the telescope, the different controls like the autofocus motor, they're all speaking to the telescope through the laptop via ASCOM. And then the ASCOM software spits out the data that the software that you control the telescope with needs. So the telescope moving software, the autofocus software, and the camera controlling software. So that's part of the trickiness in getting it all set up. You need to understand all these different components and the different links in the chain to get them all work together. And it can take a while, but once you do, hopefully they'll keep working and you can get on with taking images. So Ben asks, for a 9.25-inch Edge HD, I need 16 centimeters clearance from the telescope to the camera for deep space. Is that the same for planetary? I don't use a telescope of that design. That's a Schmidt Cassegrain. And the back focus on those, I believe, can be quite long. So back focus is the point at which the image focuses behind the mirror. And that's where you put your eyepiece or your camera. So in Ben's case, he has to have 16 centimeters from the back of the telescope to where the camera is. That varies not based on what you're shooting, but what equipment you're using with it. So if you're using a focal reducer, for example, to give yourself a wider field of view, then your back focus will change. But you don't want to do that when you're shooting planetary, because you want the extra focal length for planetary. So that probably wouldn't change the 16 centimeter back focus. You would probably just need to get yourself some extension tubes to get the camera back to that distance. When you're doing planetary stuff, you probably want to get a camera that's more suited to that. So a smaller chip with higher resolution, more pixels per millimeter. Deep sky stuff is better off with a larger sensor with a lower density, because that's more sensitive to light. So yeah, unfortunately, I can't really give you much ironclad or some concrete advice on planetary astrophotography, because I don't do planetary astrophotography generally. All right, let's have a look at what we've got here now. So that's looking pretty great. We have got 10 minutes, 15 seconds worth of photos. Let's just zoom in on that and look at it at full size, because we're only fitting it in the screen here. Now, there you can see there's actually quite a lot to this. There's a lot of detail there. It's also showing that my stars are looking a little bit misshapen. Not entirely sure why, but it doesn't really matter for the purposes of live astrophotography demonstrations tonight. But look at that. Look at these wisps in the clouds of gas and dust here, and this sharp edge between the two different types of reflection off the gas and dust. This is the same dust. This is the same gas here. This is mostly hydrogen gas. But this is like a wall here. And this side is glowing pink because it's glowing from the ultraviolet radiation coming out of the stars in the center here. But on this side of that wall of dust, that ultraviolet radiation is being blocked. And so it's getting more of its color from reflecting the color light of the nearby stars, rather than emitting the pink light that comes from glowing hydrogen. Yeah, look at that. Look at that detail in that structure. That's just beautiful. I love it. And it's so easy to reveal in this object because it's so bright. It would look a little bit sharper if my stars were better. The stars are an indicator that there's been movement through the exposures. But this is something I'd troubleshoot and spend more time working on if this was going to be an image that I'd be keeping. But because we're doing this as a live demonstration, I'm not too fussed about that, especially because when you view it at full scale, you can't really see that. So I'm going to stop imaging that at the moment, but I am going to save it, what we've got so far, because I will then process that and I'll upload it to the MBO Facebook after the stream. Come on, Archie, out of the way. As always, we've got at least one person giving an angry react. I always wonder what it is that we at MBO do that make people angry about the streams, but well, you can't please everyone. Right. Now that we've got an image of Orion, let's go back to Stellarium and we're going to find a different target. All right, I'm going to try and see if I can sync it again. Yes, good. It syncs that time. All right, we're going to go to an object right next door. We're going to go to what is called the Running Man Nebula. And that was the one that I showed you earlier that I framed separately. Looks like it doesn't actually have a name in the Stellarium. So we'll go to this star instead. So we will slew to the currently selected object, which is a Mizan Batil I, or the first. And now we'll go back to our image and we will clear that. We'll go over again to our finding preset. And that's not in the right spot. And actually, I'm going to turn off the live stack. We want it to go about here. So actually, this is the area in here. Oh, wrong one. That's going a little slow. Let's go up to 3. Oop. Big difference. All right, that should do. Go back to Stellarium and we will what's in the center of that field of view there? We've got those 3 stars there, and that little double is close to the center, so we'll sync to that one. So those are 2 stars, and I think that's the double there. So current object, sync. There we go. So now Stellarium thinks that we're pointing there, which is closer to where we're actually pointing. That'll make it easier in the future for us to find other objects that we point to. So now we go off to our imaging preset and click load. I always forget to do that. And we'll restart the guiding as well because it's in a different part of the sky. Clear that. Begin looping the frames. Pick a star. Yeah, that's not too flat at the top. And begin guiding. Now I'll go back to our imaging. Okay, now this is a much fainter object. So we're not going to see it in the first frame like we did with the Orion Nebula. I think we may also have the histogram tweaking that I did, another one applied to this one. Let's go over the live stack and see if we can tweak that up a little bit. We need to clear that. We'll give it 1 frame, and then we'll do an auto stretch, which is tweaking the histogram to make it look good. Okay. Color's way off, obviously. We can fix that. There we go. Okay, so this is a little bit of a distraction out here, but I really love the blue that we see here. So we're going to need a little bit of time for that one to catch up and get some data in order to see it clearly. So in that case, I'm going to go back over to the comments and see what we've got going on there. I'm going to have to feed him soon because he is going to get very annoying. I can see Stuart and Heike in there helping out with answering questions. That's wonderful. Thank you very much. Okay, so Jenny asks, how do you know what colors they are meant to be? That's a very, very good and difficult question. In fact, it's such an interesting and in-depth question that it is one that I spent an hour's lecture at MBO one night answering the question. One of the most common questions I get as an astrophotographer when I show people my photos is it really that color? So that's not an easy question to answer because it's very subjective and there's lots of different ways you can look at these things. So color in space is never going to be as it appears because it's too faint for our eyes to see. In order for us to see color, we need to have bright light, enough light to be able to see that. But we don't have that when we're looking at really faint objects like this. So even through a big telescope, when you look at most objects in the night sky, they don't have any color. So right off the bat, you could say, no, the color's not real. It doesn't look like that because that's not what the human eye can see. If, however, the human eye was sensitive to color in these very, very faint wavelengths, then the color that you're seeing here is somewhat like what it would be to the human eye. However, color perception changes significantly based on all sorts of things. The brain is adaptive and it adapts its sensing of color to the environment, to the location, even to your mood. So it's hard to say exactly what color something is. I could give you the well, I couldn't give you, but scientists could give you the wavelength of the light that's coming from a particular area in the sky. And then you could correlate that to a position on the spectrum, the rainbow, and say it's this color. But that sort of depends on how you collect that information, collect that data, the sample. It can be biased from the equipment that you're using. Like some lenses will filter out certain wavelengths more than others. The camera that I'm using actually prioritizes capturing hydrogen data, hydrogen light, because that's the most common light in the universe, the glowing pink color. A digital SLR blocks out 4/5 of that wavelength because it's in the near infrared, and that's considered not to help a daytime photo. So the color looks different in a digital SLR than it does in an astrophotography camera. And which one is closer to the human eye? It's sort of hard to say. The camera I'm using at the moment, though, it is sensitive to hydrogen alpha, so the pinks are more vibrant, but it is a true color camera. So it will collect the wavelengths of light as it thinks that they are. Like it'll correlate the shorter wavelengths to blues and the longer wavelengths to reds. So the color you're seeing here in my long roundabout explanation is pretty accurate to what it truly is. Although as a human with unaided vision, you would never see it. It would only be that visible if it was much brighter. And I think I'm going to just let this gather a bit of data for a few minutes. And yes, as Don says, cats always want food. And this one is going to keep pulling my earphones out until I feed him. So I will just go give him a little snack and I'll be back in a couple of minutes. In the meantime, let me put the picture on. Actually, I'll just do a quick auto stretch to see if that can make it look a bit better. And need a bit more contrast there. Not that much. Geez, the small movements are what's necessary. There we go. And I will make it bigger so you can enjoy that while I'm gone. Be right back. Alrighty, I'm back. So this, as I mentioned earlier, is a fainter object. And you can see that in order to make it visible, I've had to play with that histogram a bit more to brighten things up. And what that's done is it's also brightened up this noise in the background. So if I zoom into 100%, you'll be able to see that. So there's a lot of noise there. Now that will, over a couple of hours worth of exposures, fade further and further into the background. This is more typical of what astrophotography is, rather than a bright photo like the Orion Nebula, where you don't need to brighten things up in order to see that detail, so you don't get that noise so much. But this is why we need to take lots and lots of photos for the stacking process, which I mentioned before, where you can average out the noise in the photo and increase the signal. And it's the only way to really get a good, clean image. All right, so we'll let that go a little bit longer because it is a faint one and I'd like to get a bit more data on that. So let's have a look at questions again. All right, so Louise asks, is it possible to use a standalone telescope to take a photo of nebulas or Orion if you're manually moving it yourself? I'm afraid not. The movement has to be very, very precise. It has to follow the motion of the stars exactly, because if it doesn't, then the projection of the image onto the camera sensor will move across the sensor and it will make star trails. It is literally impossible to move it by hand with that precision. There are some objects, though, that you can potentially photograph with your smartphone through an eyepiece of a telescope. So the bright objects, such as the moon. The moon can look really spectacular with a smartphone photo. And a lot of our members do that, and a lot of the public do that when they come up to our observatory for our public viewing nights. The planets also can be okay with smartphones, but generally you want a camera and tripod. All right. Let's see. Thank you for the comment there, Stuart. Oh, and you're using the screenshot I took of you as your as your profile pic. Perfect. I love it. Stuart's a very, very trendy space nerd. Folks may hopefully recognize him from our previous live streams. Yes, the cat's name is Archie. Ruth has got an interesting question. Can stars affect us on Earth? Obviously, the sun can affect Earth, so just wondering if other stars can. Generally, no. The distance to these stars is so far that their influence, you may have heard of the inverse square law. That's basically a rule of physics that says the further you're away from something, the the rate at which the light or the gravitational waves or the other energy from it drops off is inverse square to the distance. So if you double the distance, you 1/4 the strength of something. So the light from the sun, if we were at twice the distance from the sun that the Earth is now, it would appear 1/4 as bright. If we were at 3 times, or say 4 times the distance, it would appear 1/16 as bright. So the nearest star is 46 trillion kilometers away. So the number of times that has been dropped off is over and over and over and over and over again. So the energy from the star is not going to affect anything on Earth. However, stars do affect us culturally. We have long used the stars to tell stories. Most cultures, if not all cultures on Earth, looked to the stars and they saw patterns, and they used their storytelling to explain those patterns, or to use those patterns as props for the storytelling, as guides to help people follow the story or understand certain things. It's a part of an oral history. And it's very important for passing those stories down and for teaching people lessons, which is the purpose of most stories. Stars have also been used for navigation, for timekeeping. The Egyptians knew when the Nile was going to flood because when Sirius would rise. Things like that. That's how the stars have influenced life on Earth, but it's not a direct influence. There's no way that any star in our galaxy, even a supernova, could affect us, because there are none near enough to have that effect. Oh, sorry. I'll answer Grace's question, then Petra, I'll get you to put back that other one. But Grace's question is one that I haven't actually answered yet. We are looking at a nebula called the Running Man Nebula. It's a bit of a weird name, I know, but we're actually seeing it upside down from the Running Man perspective. But if you look here, you've got a leg here, upper body, and an arm behind and an arm in front. So it sort of looks like someone running. At least that's how it looks to the people who named it when they're probably looking at it through a telescope. It's a beautiful reflection nebula. That's why it's blue. It's reflecting the light of these blue stars. And embedded within it are some rivers of emission nebula. That's the pink purple stuff you can see there. That's where the glow from energized gas has overwhelmed the reflection of the gas, the light of the stars on that gas. So Petra, if you wouldn't mind, from Michelle. Michelle asks, what planets are visible at the moment? Jupiter, Saturn, and Mercury are all visible in the western horizon towards where the sun sets, not long after the sun has set at the moment. I think Mars is up as well, and Venus is up in the morning. Venus is a morning star at the moment. So I think that's all at the moment. That's all the naked eye visible planets. The naked eye invisible planets, the ones that you need a telescope to see, I believe some of them are also up, but you'd need a telescope to see those. Planets aren't really my thing. I'm more of a deep sky guy. All right. Well, we've got probably enough data on this object now. Let us do a last little tweak to see if we can make it look a little bit nicer. We'll probably darken up the background a little bit to get rid of some of that noise. So I'll just bring that up a smidge, And then I'll bring that back down again. Yeah, about there. It's a little bit higher contrast than I'd like. I'd want to get more time on this to get rid of this grain here. But it's still very pretty for what it is. So we'll save that. We got 13 minutes and 30 seconds there. So save that image, and we will stop the live stack and go back to our finding presets. So I'm going to go another object in this vicinity, which is a very famous one, and you should be able to recognize it, but I'm not going to tell you exactly what it is until we get there. So we're setting the telescope just over in the neighborhood. So these three stars here are the famous belt of Orion, and this shape here is the saucepan. So next time you go outside and look at the saucepan, look at the handle. It looks like three stars, but the middle star is actually the Orion Nebula, the one we shot right at the beginning. All right, let's see if we have anything visible in there. Not really. That's okay. There is something in there. Trust me. Let me just make sure I'm in the right side of things. And yes, I am. So let us go to our imaging and see how long it takes for it to reveal itself. We'll go into the live stack as well. And we'll reset all of our tweaks. All right, so Ben asks, what are the programs you're running? In the foreground, there's behind the scenes stuff. There's the ASCOM and driver software and stuff like that. But in the foreground, I am running SharpCap Pro, which is this software here, the imaging software. It is used to control the camera. Let me just quickly tweak that to see if I can get the color looking a bit better. There we go. So while it's collecting data, it'll at least have the right color. I'm also using Stellarium, which you should be able to see the name up there. Stellarium is a fantastic planetarium software. I have tweaked it substantially to make it work for me and for my astrophotography. I actually have a 360-degree panorama here of the view of my backyard from my telescope's location. So I can tell that looking at this here, this is going to go into the roof of the house pretty soon. So that's why I'm starting with Orion, because these are there's an area of the sky that we're not going to be able to see for more than another hour. Those are the two pieces of software I'm using primarily. I'm using PhD because as my guiding software. My guiding's pretty terrible tonight. I must have set things up properly, or it must be a bit windy out there. But this just helps to keep things pointing pretty much in the right direction. And this over here is called EQ Mod, and that's just the telescope driving software. And it's mostly a background piece of software. It stays out of sight most of the time, but I just use it when I need it to take over the pointing. Okay, Naomi asks on behalf of Liana, 6 years old, a fantastic question about black holes. Why are they so big and so far away? Well, I happen to know that we have an expert in black holes in the chat at the moment, and that is Stuart. Stuart will be able to give a better answer than I can, but in brief, black holes are not necessarily big. They can be very, very small. In fact, they can be micro black holes. But they can be very, very big. And when they are very, very big, they tend to get bigger because they have a much greater gravitational pull and they pull in more stars. And that adds to their mass, which makes them have more gravitational pull. The reason they're so far away, well, they may not be far away. The nearest black holes might be so close, but still small, but we can't see them. Now, the only way you'd actually see a black hole is if there's stuff being sucked into it, because the movement of the stuff being sucked in actually generates energy because it's moving so fast. And we can see that energy. But if there's nothing actually being sucked into a black hole, we don't see any energy nearby. Therefore, we don't see the black hole. And if it's small enough, then it won't influence the movement of stars nearby. So we would have no idea that it's there. The big ones, though, they are usually at the centers of galaxies. And the galaxy core is a long, long way away from us. So that is generally why the biggest black holes are far away. If they're smaller, they might be closer, but we're also less likely to be able to see them. Okay. Oops, sorry, Petra. Just a quick comment. MBO asked, I hope Neil answers this, but just as a point, if they were close, we would not be here to talk about it. Very true. It depends how close they are, but yes, if they were very close, it would be difficult to talk about them. So sorry, Petra, what were you going to put up for me? For those who joined us late, Petra is helping me out in the background, doing some technical stuff and popping up questions for me occasionally. Pardon me. Sam asks, how long on average do you need to take a shot for the best photo? How long is a piece of string is kind of the answer, especially when you said the best. If you had your choice, you could capture data for hours and hours and hours and days and weeks. The Hubble Space Telescope captured a famous image called the Deep Field, and it did 150 hours worth of exposure on that particular image. The longest I have ever done is 17 and a half hours, and that was done over the course of 3 nights in a row. I was able to leave my telescope set up, and it was clear for that whole time. So I chose the same target for those 3 nights in a row, and it made a difference. It helps you to reduce the noise and bring out really faint details. But typically, I won't be happy with a photo unless I get 2 to 6 hours on it. If I can't get at least 2 hours, then I'm pretty sure that I'm not going to be able to do a lot of editing with it to make it look brighter and show the details and the contrasts. 4 is usually pretty good for most bright nebulae, like the Orion Nebula or what we've been imaging tonight. If you wanted to do something fainter, then 6 is probably more likely. Any longer than 6, and it starts getting difficult because then you need to be shooting the whole night. And if you've got summertime, we don't have 6 hours of dark skies. Wintertime, you're more likely to have clouds come over. My dream is to get a small roll-off roof observatory built in my backyard so that I can leave my telescope set up, and then I can just image every time that the sky is clear at night. And that means that I can do images of objects over longer periods of time, over several days. So ask me again when I've got my observatory what I would be happy with as my average exposure time, but at the moment it'd be between 2 and 6 hours. Matt asks, have I used SharpCap for a while for capturing? I am only just starting to play with LiveStack, but what's the difference between capturing in RAW 16 and RGB 24? Hard to give the specific details. I don't ever use RGB 24, but that's because I only ever use RAW for any photography. RAW is very important to get the maximum possible amount of data in the photo. And I just realized I'm leaving you watching the boring guiding data rather than actually imaging. So let's see how that's looking. Okay, I'm just going to tweak this, then I'm going to come right back to your question. So let's tweak it so we've got something to look at. Bring up the darks a little bit. I wonder if anyone can see what we're looking at yet, because this is a much fainter object. Let's try tweaking the color balance. Yeah, that's a bit better. All right, so back to your question. Thank you, Petra. RAW is all of the data that the camera captures. RGB is the software processing that data so you can look at an image straight away. It's the equivalent of using JPEG in an SLR versus RAW. I would recommend always using RAW for that reason, to get the most out of the camera. As for using SharpCap, I basically use the minimum feature set, essentially. It does what I need it to do for live imaging. I don't usually use SharpCap for my day-to-day astrophotography when I get the chance to do day-to-day astrophotography. I use another piece of software called Sequence Generator Pro. that's better suited for long-term exposures of single objects. Sharp cap is great for rapidly moving between one object to the next in order to be able to show folks things in rapid succession. I just realized my camera has got my face below the comments, so I'll move it up a bit so I can keep making eye contact with you. So yeah, Sharp Cap is fantastic. I'm only using a portion of its features. I figured it out as I went along. I'm guessing you're doing the same thing. So I'm sure you'll learn the best way to use it. But again, I recommend using RAW. 16 is probably better than 18. Than 8. It's a bigger bit depth, so it captures more data. So yeah, that'd be my recommendation. Michelle asks, why do stars look like they're twinkling? So next time you get a swimming pool, look at the bottom of the pool at the lines where there are the lane markers that swimmers watch. And do they look straight? Well, you might say, yeah, they look straight because they're painted straight. But when you're looking at them, you see them wavering and shimmering and moving around because the water is bending the light coming from them. Well, the atmosphere does exactly the same thing with the light coming from a star. So the atmosphere is not one smooth, even, continuous gas. It is gases of different temperatures, of different densities, and they're always moving around, the wind blowing them. That density difference causes the light passing through it to be refracted, to be bent slightly. And the result of that is the star appears to twinkle. You may or may not have noticed that stars twinkle more when they're just rising or setting around the horizon. But when they're straight overhead, they twinkle far less. That's because looking straight up, we're looking through less air than if we're looking across the ground, we're looking to the horizon, we're looking through more atmosphere. It's like cutting a thin slice across the edge of an orange, and you can see you've got a whole lot more peel that's revealed. Whereas if you cut it straight down the center, the peel is only a very thin layer on the orange. And so the less atmosphere you look through, the less twinkling you'll get. And that's the reason why the Hubble Space Telescope was put in orbit, to get away from the atmosphere. Grace asks, what was the satellite that just sped past? I didn't see it, but one of the people in the chat might be able to point you to a resource. There's a website online that lets you look up satellites and see which ones are where and when. I'm trying to remember what it's called. The name's escaping me right now, but hopefully someone will come to your rescue and answer that one for you. FJ Brady, Michael Boss wants to know the best way to start off in astrophotography. That is a question I actually answered in our Christmas special. It's a little bit long to go into just as a quick question here, but I recommend you go to the MBO Facebook page and look back in our recent posts. Go back to December 24th, and you will see a short video where Andrew and I answer half a dozen questions from folks that were left during our live streams that we didn't have time to answer. And that was among them. So that will answer your question. Maybe someone in the chat will give the answer. All right, let's just pause on the questions for a moment, and we'll go back and have a look at this and see what we're getting. Let's try and darken up the background a smidge more, and then brighten up the midtones a smidge more. Okay, we're getting some rather nasty green there. Let's see if we can fix that at all. No, definitely not. All right, let's do it manually. We'll drop the greens a smidge. Not that much. It's a bit better. Maybe bring up the reds a little. Yeah, that's not too bad. So it's upside down, but who recognizes this? Huh? Look familiar? Turn your head upside down and tell me what you see. Let's see who can say it first. Scrolling down. Don't think anyone's guessed it yet. Oh, actually, no, we did get a guess. I may have missed one earlier, but we got Kevin, Horsehead Nebula. That is correct. Again, this is a very faint object, and everything's not configured at its best at the moment because this is a live astrophotography. And if I was doing this, properly, I'd be doing things slightly differently. It'd take longer, but I'd get cleaner results. But you can clearly see there, upside down, there's a little horse's head sticking into that sheet of red there. I always thought it looked like a chess piece, the knight's piece on a chessboard. So yes, this is the Horsehead Nebula. Can I make it full screen? Yes, I'll make it a bit bigger than that. Let's bring that down. And I won't zoom in too far because it just makes the noise look a bit bigger. But you can zoom in a little bit. Yeah, it's a pretty thing. Unfortunately, I can't turn it upside down in the viewer. There's no image rotation in the viewer. I would need to save that out and edit it to do that. But I'll do that when I finish the sequence on this one, which I'll probably finish up soon. But it is a very faint object. It takes a while to get the data that you need for that. It's one of those objects that's actually so faint, it's very difficult to see even in a telescope with decent sized telescope. I think I convinced myself I saw it through MBO's 14-inch robotic telescope. Okay, I think we should go over to a new object. So let's save this one. We're doing 10 to 15 minutes on each object, which is pretty good. We'll clear that, leave the live stack, and let's have a look at Stellarium, and I'll see if anything jumps out. Ah, yes, we had a request for Betelgeuse. Let's do that. So far tonight we've been looking at nebulae, but we are now going to look at a star. And if we go over to our camera, we can see the telescope moving. Okay, it wasn't far away, so it didn't move far, but it's still cool. I love seeing that. Getting a little bit hoarse. Okay, I think we found Betelgeuse. That is definitely a bright orange star. Let's go over to our finding mode. There we go. All right, let's turn on our crosshairs so that we can center it. Go back down to 2 times speed. Other way. All right, since we've got such a bright target and it's very clearly centered, I'm going to use that to synchronize the Stellarium again, because every time you synchronize it, it improves the pointing model a little bit. So it means that if you go to point somewhere further over in the sky, it will be closer to the center. All right, now this is an object that won't take too long to get a good image of, because stars are bright. In fact, let's just do a single image and see what that looks like first. So 5 seconds left. And there we go. Pretty. We'll do a live stack anyway. Probably doesn't need it, but we'll do it anyway. Just because I want to see if we can pick up lots of background stars as well. So while it's doing that, let's see if there's any more questions. All right, Julie, what's the furthest object that has ever been imaged? Interesting question. And I'm going to specifically pick out the word object there, because the most distant thing that's ever been imaged is what's called the cosmic microwave background. And that is the glow left over after the explosion of the Big Bang. And that is not actually an object. It's just heat. Very cold because it's had a long time to cool down. It's 3 degrees above the absolute zero, but it is at 13.7 billion light years away, thereabouts. The furthest object, however, is a very, very faint, very red shifted, because it's traveling away from us, stretched out the wavelengths of light so they become longer, so it looks more red, galaxy. And that, I believe, is at about 13.4 billion light years away. That's billion with a B. If you don't know, a light year is the distance that light will travel in a year. Light travels at 300,000 approximately kilometers per second. So how many seconds are there in a year? Well, multiply that by 300,000 and you get a light year. That's around about 10 trillion kilometers. 10 trillion kilometers in 1 year. So 13.3 billion times 10 trillion is how many kilometers away that is. That's a long way. It's so far really that we can't comprehend it. I'm just going to quickly tweak the color on this. No. Better. Yep. Now, the very center of this is actually looking a bit wrong because Betelgeuse is so bright. In 15 seconds, it completely overexposes the center. And there's no real way to get that color exactly right. But I'm going to keep going because I want to see what we can get in the background. Yeah, it's looking pretty nice. But we'll go a little bit longer. All right. Get that off the screen. There we go. All right, another question. Thank you, Petra. You were right on the ball tonight. Ben, how did you align your scope? The telescope tripod legs I put down roughly pointing south because I've set up my telescope in my backyard many times before now, and so I have a pretty good idea of the general direction. But then I used a piece of equipment called a pole master. It's a camera that I attached to the mount of the telescope, and I can actually show that to you. There. So this here, this little camera, that is mounted perpendicular, or the base of it is perpendicular to the polar axis. So a line from here through the telescope mount to the back here is the polar axis. And so this mechanism, it rotates around that. So this should be, because everything should be flush, pointing exactly where the polar axis is. That lets me use the camera to look at the night sky and pick out a pattern of stars that are located around the South Celestial Pole. And if I can get them in the right place by moving this knob to move the up and down here, and these bolts to move it left and right around here, that lets me get the axis perfectly aligned with the Earth's pole. I can actually show you the software that I use to do that, and even the view from the camera, because that is still connected. So if I make that full screen, connect it, this is the view of the South Celestial Pole from the polar alignment camera. So the group of stars that I use, we'll just get rid of that to, let me see, these are the instructions on how to polar align. It's just getting in the way a little bit, but there's a group of 4 stars. So that one, actually, I think my pointer might be slightly off, but it's that one, that one, that one, and that one. So it's this group of 4 stars. If I actually click on it, oh, look, there's a star going through there too. We'll finish that. I'm just trying to bring up the guide, because that will circle the stars. Oh, it's not bringing up the... Never mind. I can't really show you right now, but you can see that little red dot there. That is the star that I use primarily. Those 4 stars together, and that one is the main one. That tells me where I am, and the South Celestial Pole is around about there. Oh, there's the guides. So I can click on that, rotate this around to there. So 1, 2, 3, I use that one, but the software uses one up there. That means that this little dash circle here is where the South Celestial Pole is. So by using the camera to find where these stars are, I can get this where I need it to be by moving the telescope mount up, down, left, right. Hope that wasn't too confusing. It was a little bit muddled. All right, let's see how Betelgeuse is going. That is looking lovely. There we go. What a beautiful bright orange star that is. And we've got 6 minutes of exposure, and we probably only needed 1, but it looks nice. I'll let it go for a minute more, and I'll just see if there's any other questions. Oh, I should turn off the background. There we go. Go back to chat. All right, Rose asks, what is a good starters program? It's a bit of a vague question, so I'm going to assume you mean a program to learn about astronomy. In that case, I recommend Stellarium, which is what I'm already using here to find my way around the night sky. I'm using it for a technical purpose, but it doesn't have to be anywhere near as technical as this. You can just use it as a way of looking at the night sky. And if you set the time and date in here to the current time and date when you're looking at the stars, it will match up with the night sky. So you can say, oh, what is that star? And then go into Stellarium and look it up. Or the other way around, you can use Stellarium to find some interesting objects and then grab a binocular, pair of binoculars or a telescope and try and find that object in the night sky yourself. That's probably a good way to get started learning about the night sky. Of course, also becoming a member at MBO is a great way to learn. JB Tinker, we just moved into the area. Is there a good publicly accessible dark site in the area, park, dam, reservoir, etc., that you would recommend that we could take our telescope to? Just a few too many lights near our house. That's a tricky one. Most places that have public access will have lighting at night. Also, the light pollution near, like even small towns like Emerald, can be significant enough that it can affect that. If you're in the area, try your backyard first of all, because the area around here is pretty good. I'm in Cockatoo near Emerald. So our skies here are quite decent. But if you are near the lights, as you say, too many lights near your house, try using Google Maps and look for reserves and parks. And you ideally want to have one that's big and that is open at night. Something like Orovale Lake Park or what's the dam? Cardinia Reservoir. That might be good. But those two are both sort of the Melbourne side of Emerald. Ideally, you'd like to go further away from the city. So if you go further out past Gembrook, for example, they'd be good skies, but you might not be able to find a place that doesn't have lights as well. Try using Google Maps. That should hopefully find some reserves for you, and then maybe drive around during the daytime and see if you can find any place that you can park your car that doesn't have street lights within view. Ben says, shoot the lights out. I don't recommend that. Okay, let's have a look at Betelgeuse and then move on to another target. Oh, yes, Stuart makes a good comment. Up at MBO isn't too bad. Definitely. Become an MBO member. And in fact, Petra, once you're taking Stuart's comment off there, why don't you pop up a banner giving people the link to MBO's membership? There we go. Fantastic. Thank you. So, yeah, lots of great reasons to join MBO. I won't go into them now, but having access to a dark sky site with lots and lots of really knowledgeable people and telescopes that you can freely use is a fantastic reason to join. And we have good dark skies too. Not the best dark skies, but we're within an hour's drive of Melbourne, so the best you can get within an hour of Melbourne. All right, one last look at Betelgeuse. Lovely. Look at all those background stars. There's a lot of stuff going on in that area because it is near the Milky Way. So that's only 10 minutes, but we'll save that as is. Clear it and stop the live stack. So let's see how we are going for objects. So we're in this area over here. Oh yes, this is a lovely one, the Rosette Nebula. So the Rosette Nebula is a very hydrogen-rich area. So that means you can expect to see lots of red and pink nebulosity. Let's see what turns up. Okay, I do recognize that little cluster. I believe that is in the Rosette Nebula, but we will go to our finding preset and we will make sure. Okay, now the Rosette Nebula is kind of faint, so it's not going to show up immediately. So let's just center this a little better. And then we'll go into our imaging preset and start a stack. I'm pretty sure that's the cluster in the middle of the nebula. All right, we'll do one 15-second exposure and just to see what it looks like. And if I'm confident that it was still in the right area and if we're in the right spot, then I will start up a sequence. Okay, we're going to need to go into live stack and reset the stretch. So we'll try that again. Hello, Belinda. Lovely to see you here. I'm glad you can make it. Belinda is a new friend of mine that I met through live streaming. So it's been wonderful getting to know you. And I'm glad you've become a member of MBO. We look forward to seeing you up there sometime soon. Belinda has done what you should all do. Become a member and become excited about all the cool things that we do up at Mount Burnett. All right, so let's go back to our view here. See if we can get the stars looking good. Yes. Try and auto stretch. Okay, that's definitely faint. So we might need a bit more time on this before we start to see anything. Ah, yes, I can see some stuff there. See this faint mottled red in the background? Let's give it a bit more time. This is one of those objects that is spectacular when you give it the time it needs. Okay, so we've only got 60 seconds on there. Let's see how it looks after 10 minutes. All right, let's see if we've got any other questions. Okay, Con asks, what size and type of scope is your current dream deep sky astrophotography telescope? Okay, give me a minute and I'm going to go and find you a link or a picture. It'd help if I spelled it correctly. What happens when you rush? Okay, maybe I'm not going to find it that way. Give me a second. Let me see if I can find the best photo of it. This is actually a custom build. So not one that I'm getting built for me, but it is one that some friends of mine who in the last couple of years started an astronomy store. They are coming up with a astrophotography specific design telescope because they're astrophotographers. Let's see, will that bring it up? There we go. So it's on a Facebook page of the friend who posted it. But this is a 12-inch, 30-centimeter diameter F4 truss Newtonian reflecting telescope. So it's all made out of carbon fiber and steel. It's machined on a CNC machine, all the custom parts. It is made by Diego and Paul from Sidereal Trading, and it is made specifically for astrophotography. So it's got all the precise tolerances. It's got a nice fast aperture. It's got perfect optics. And it would be an absolutely magnificent beast to stick a camera on a huge mount, as you can see there. That's a much heavier and stronger mount than I have. And really, once you bought that telescope, there's nothing that you couldn't shoot. Of course, you'd have to have it set up in an observatory. This is not the sort of telescope you can move from location to location. Again, it's not ideal for planetary. Again, you want to have equipment that's good for planetary and lunar, or for deep sky. There aren't really many telescopes that will do both. But this one is a dream deep sky telescope. It'd give you great results on pretty much any object you wanted to point it at. It would be precise in its positioning and its tracking. You would not have to worry about the alignment of the optics. The truss would keep it nice and stiff and strong. Once I got one like that, I'd have it set up and never touch it for years and years and years. When I say never touch it, I mean never adjust it or move it. I'd control it remotely, but it would do everything I wanted it to do. So yeah, that's my dream gear. Naomi asks, is that cluster known as the jewel box? No, the jewel box is actually a different one. And I think I might be able to go to that tonight. I'm not sure if it's up. Actually, I can show you. We'll go back to the other monitor. Ooh, infinite. So this is a tool that I use to help me find out if what objects are up and what I can see. So here's the jewel box that's in my list. Yes, it is above the horizon. We'll go to the sky view. This green area here in the all sky view is my local horizon. I have a good horizon out this direction. So there is the jewel box. It's actually quite low in the sky at the moment. So it's not ideal at the moment. Once it rises above this red dashed line, that's sort of the rule of thumb position where the sky is better because the atmosphere is not as thick. It's 30 degrees above the horizon. So I won't wait for it because it'll take an hour to get there. I won't wait that long to go over there, but I will wait a little bit longer, and it's going to get better throughout the night. I'm sticking over here for now while we have it before it disappears over this way, although it'll probably be another hour or 2 hours before all of Orion disappears, and I think we're now out here towards the Rosette Nebula anyway, so that doesn't matter too much. We can go and have a look at that soon. All right, let's have a quick tweak on the photo now and see how it's coming up. All right, that's starting to look good. That's better. I'll drop the green a little bit and push up the saturation more. Even more. Can you see that coming out, folks? Wasn't there at all to start with, but with a little bit of tweaking and a little bit of exposure time, we're starting to get something. So that's 6 minutes now. Let's zoom in on that a little bit more. Let's go to 50%. Now you can see there's a lot of colorful streaks in there. That's the grain, the noise in the photo. That will reduce significantly over half an hour, an hour's time. We won't do that tonight, but this is an object that I will be photographing again sometime soon. But you can see here, we've got this beautiful red nebulosity. We've got some dark lanes passing through it there. They're nebulosity that is closer to us than the stuff that we're seeing on the other side. And it's far enough away that it's not being illuminated by stars, and so it's dark, and it blocks the light from behind it. Okay, let's go back to the chat. Mike asks, hi Neil, what is that software you just showed to see what's in the sky tonight? Yes, I should have answered that or made that comment. This is called Astroplaner. That's the name up there. It is, I think, $45 US, but it is really, really helpful because you can tailor it to yourself. So as you saw, I put my local horizon in. I did that by taking a 360-degree photo from the position of my telescope and then plotting out onto that the coordinates, the altitude and azimuth coordinates, and then plug that into this software so it could position itself relative to my view of the sky. And what it does is it lets me see when in the night it will be up. So we can see here, it rises behind my local horizon at around about 2100 hours, and it gets higher and higher and higher until here, that dark blue column there, that is Oh, I just realized it's not sharing it. Sorry. There we go. It's a bit small because I'm using a 4K monitor. So it's a bit hard to see what I'm pointing at. But so this is the list of targets. This is the jewel box currently selected. You can see here we've got this dark area here. That's night. So this is the hours of the day. The white line is the current time. The red pluses are the position in the sky, the altitude-wise, throughout the night. So the target rises above my horizon about 2100 hours. And around about 3 a.m., it starts to get into morning twilight. So you want to finish up your photos before then. But it gets higher and higher throughout the night. So that's really handy. But this chart is really useful because it tells you the maximum elevation of the object at different days of the year. So it will be best observed in May, so early May. A different object, so for example, let's see, the Eta Carina Nebula, and that's in the same area. Let's go the Lambda Orionis Nebula. That is not a winter object. It's only really visible in, well, now, around the beginning of the year. Right now, it's at its highest point in the sky for me, but it's about to set behind my local horizon, which is the roof line of my house. If we click on sky, we'll be able to see it highlighted. So that's it there. And these lines here, they're the direction that the stars move as they rise and set. It's got about an hour, maybe an hour and a half, until it goes behind the roof line there. At the moment, we're imaging out here, the Rosette Nebula. So yeah, Astroplanet, very handy if you take the time to put in your local horizon, if you're always observing from the same spot. All right, let's see how we're going with the Rosette. Let's go back out to full size. Yeah, that's starting to come through now, particularly down here. It's a bit brighter in this area of the nebula. But if you recall what it looked like when we first started, it's come a long way. Again, this is an object I'd really like to spend 4 to 6 hours on to get that brightness that you really need to get rid of that noise. But you can do surprisingly well in just 11 minutes, as you can see here. All right, let's see if we've got any more questions. Belinda, I came in late. What are we looking at here? Right now, we're looking at an object called the Rosette Nebula. It's called that because it looks a little bit like a rose. You can see the sort of the center there with petals around it. And it is, I believe it's a supernova remnant. That is the gas and dust from a star that has once exploded and spread its body throughout the region of space around it. The gas and dust that it spread around, and when it intersected with other gas and dust in that area, it clumps together, and it actually started to pull together under its own static forces at first and then gravitational forces. And that gas and dust is actually starting to form new stars. And this cluster in the middle here, you can see, is the forming of stars from the gas from the supernova and from the stuff that was in the area around it at the time, forming from that. And you can see the dark hole in the middle there. That is because these stars, which have ignited after collapsing from the nearby dust, when they ignite, they burn and give off light and energy, and they give off stellar wind. We have solar wind in our solar system, and that pushes through the solar system. Well, these stars have stellar wind, and they're pushing out the nebulosity from the center of this cluster here, because the gas and dust gets pushed away by that. So that's why we see this hole in the middle. But these loops here, these sort of edges of the shapes there, that's as the result of the supernova spewing out the gas and dust from the explosion, and it running into the shock waves from that, running into and compressing the gas and dust that was already in that space. Anthony asks for Eta Carina. Great suggestion. We will go there very shortly. Just want to bring up here Mount Bennett Observatory. That's Hiker. Wow, just noticed how late it is, but that's kind of how astronomy works. Absolutely. And I'm kind of notorious for going for many, many hours on my streams. So we're already an hour and a half in, but I think we'll finish at midnight. I've actually had a tiring week. So I'll finish up at midnight and get some rest then. But before we do, Anthony has suggested a very wonderful target, which we should absolutely go to. Just taking a last look at the Rosette Nebula, it's such a lovely object, and I really do want to return to it and get a photo of it this season. All right, so we shall save that at 14 minutes. Clear and pause. We'll reset our histograms. And we will go to Stellarium and find Eta Carina. All right, so we will slew to the current object. Let's go over and see the telescope moving. There we go. I just love watching that. It's so cool. Stuart makes a great point to follow up my explanation of the Rosette Nebula. As the stars push away that gas and dust from their stellar winds, it will compress that gas and dust in front of it like another shock wave, and that will trigger the formation of more stars. So as long as there is gas and dust of a sufficient density in a region, the formation of stars will trigger a burst of formation within that gas and dust. Heike comments that it looks like a robot, and that's absolutely true. It is a robot. It's controlled by the computer, and it has motors and servos and all that sort of stuff. So yeah, the telescope is a robot. It's a robot with an eye. A few eyes, actually, with the guide scope on top and the polar alignment scope there. All right, let's see if we have found Eta Carina. All right, we will quit live stack for the moment. We'll go over to our finding presets. Now this is another bright one. Unlike the Horsehead or the Rosette, which we just had and we struggled to see without longer exposures, Eta Carina is more like the Orion Nebula in that it's very bright and very quick to get impressive photos of. So let's center this a little better. Probably around there. And I'm going to turn on the guiding for this one because I keep forgetting to do that. We will stop that. Pick a new star. No, that's too bright. How about that one? Yeah, that's good. And start guiding. Now we will go to our imaging preset. And we'll go straight over to the live stack because I know we've got it. And let's see what it looks like after the first 15 seconds. Brace yourself, this is going to look good. There we go. How good is that? Color's way off, but we can fix that. Let's auto stretch that. There we go. Look at that. How good is that, folks? This is an absolute stunner of a nebula. It really is gorgeous. Even after, 3 frames of 15 seconds, we've got something that looks that good. Let's zoom in a little bit and have a look at some of the detail there. So this here is the star Eta Carina. It is a cataclysmic variable of 2 supergiant stars, one weighing approximately 30 times the mass of the sun, the other weighing between 50 and 60 times the mass of the sun. Absolute gargantuans. And they're in the same system. They orbit each other, and they are incredibly violent, which is why the name cataclysmic variable came about. The bigger star, or the heavier star, rips the atmosphere off the smaller star and sucks it into itself. And it does that continuously, but there was a big event a few hundred years ago that it caused an explosion that pushed out such a huge quantity of mass. It was about 20 to 30 times the mass of the sun in one explosion. So these stars absolutely tore themselves apart during this big eruption. They still survived though, and they still orbit each other. But this eruption was just absolutely gargantuan. Astronomers believe that this is likely to be one of the next candidates for a supernova explosion in our galaxy. It's far enough away that it won't impact us directly. However, when it goes up, it's not going to be a supernova. It's going to be what they call a hypernova. Astronomers love using really descriptive names. It's a hypernova because not only are the stars both supermassive, much, much bigger than most stars, there are two of them in the same system. When one goes off, it'll trigger the other one to go off. And it'll be so bright, it'll be visible in daylight. It'll be as bright as the full moon. And it'll be like that for several months, maybe 6 months or more. I would love to see it, but at the same time, it would rule out any astrophotography of any other kind for the rest of the time that it was bright, because it will overwhelm the whole night sky, just like the full moon does. So yes, the Eta Carina itself is a stunning, incredible, superlative star because of what it is. It's all the extremes in one place, but it illuminates this incredible, beautiful nebula. Now, I don't know, Stuart or someone else might be able to correct for me, but I don't know if the gas and dust that it's illuminating here is actually the result of previous eruptions from Eta Carina, or if it's just coincidence that it happens to be amongst that dust. But because it's such a bright pair of stars, it illuminates a lot of dust in the nearby area out to much further distances than most nebulae, and it makes them much brighter than most nebulae. This one can actually be seen with the naked eye if you know where to look. It's just to the west of the Southern Cross. And it looks like a faint fuzzy patch in the area of the sky. It's about 2 degrees across. We're only looking at a small portion of it here. It continues off down below the bottom of the screen. And through a pair of binoculars, it looks amazing. Through a telescope, it looks incredible, but you can only sort of see this central area through a big telescope. If you become a member at Mount Bennett Observatory, come up during summer when we have members' nights. We are absolutely going to be pointing our telescopes at this object, and we have a big 18-inch Dobsonian telescope there, and this object looks absolutely stunning through it. Worth the price of admission for that reason alone. All right, so we got any other comments or questions? Stuart has a nice addition to the description of the Rosette Nebula and the stars. The actual mechanism that would allow them to blow out such amounts of mass while not completely, we're talking about Eta Carina, while not completely destroying themselves is still being discussed by scientists. So we don't know how Eta Carina could have had such a massive eruption, shedding so much mass without destroying the stars. That's a mystery. So a great one for you to work on, perhaps, Stuart, if that's your thing. Yes, Hiker MBO's hypernova. It's one of my favorite words in astronomy too. It's just so over the top. It's like something from a Marvel movie. Hypernova sounds like a supervillain or a superhero, doesn't it? Yes, thank you, Hiker, for putting the link out there. Visit mbo.org.au to join us or to visit our shop for some cool merchandise. It is out of this world, spacey merchandise. All right. Hello, Ella. Nice of you to join us again. Great to see you. Looking forward to seeing you in person, hopefully soon. One of our new members who has become very excited and very keen to help out at MBO. We love our enthusiastic members who volunteer and help us out because it helps us do more. We're all volunteers at MBO. I'm volunteering right now. So what you're doing here is seeing me do this for fun, for passion. So we're all a lot like this. Well worth joining so that you can hang out with cool people like us and share in our passion. Grace is asking, how do you spell it? I'm going to put it in the comments. We are looking at the Eta Carina Nebula. There you go. You should see that pop up in the comments from Mount Bennett Observatory, because that's the account that I'm logged into here. Ella is saying that she's going to be bombarding me with astrophotography questions when we meet. Good. I hope so. I love teaching astrophotography, especially to people who are so excited that they want to bombard. So I'm looking forward to that. When you do, make sure you bring your camera and tripod, and I won't just teach you how to do astrophotos. I'll show you so you can take something home that you've done yourself. All right, let's have a closer look at this now that we've got a few minutes of data on it. We've got how long? 28 frames for a total of 7 minutes. Let's see if we can pump it up a little bit more. I don't want to go too much on the dark because I don't want the contrast to blow things out too much. But yeah, that is looking really lovely. Already at max saturation, I reckon. It could even do with more with a bit of editing. So let's pop that out of the way and let's zoom in to say 75%. Oh, still a bit of noise there. So we'll go back out to 50 so the noise isn't so distracting. But everywhere you look in this area, there's just beautiful nebulosity and structure. It's a very, very active region, very dense with stars and nebulosity. This particular area here is where it's densest, and you can really see a lot going on. If I zoom back out again, actually, this hard edge that you can see there, the right angle edge, and it's sort of a wedge of darkness here and a wedge of darkness here. That is not a hole in the nebula. The nebula is continuous behind that. It's actually dark gas and dust that is not illuminated, that is between us and the Eta Carina Nebula, and it is blocking the light from behind from getting through. Most of these stars that you can see in this area are this side of the dark nebula. It's interesting, though, that it is such a sharp edge and an almost 90-degree angle there. It's just a lovely cosmic coincidence. But this shape here, you can see that clearly when you're looking at it through a telescope. Even a small 6 or 8-inch telescope will see that structure. But in the larger 18-inch Borg, it is very striking, very clear. Diana, thank you very much. We love to blow people's minds. The favorite thing that we hear and the greatest reward that we get when we're doing outreach events at MBO is hearing people say, wow. And we're lucky that we've got such cool things to show that we hear that a lot. We are having a members' night soon. I'm not going to say the date in the public page because, one, we may need to change things at the last minute depending on the latest advice from the government. And two, we don't want people just rocking up at our location if they're not members, because it's going to be a members-only night. If you are not a member and you are very keen to come up and see MBO, the only way you're going to be able to do that for the foreseeable future is as a member. We won't be opening up to the general public until things are settled down even further. We're doing pretty well battling COVID right now, but we're probably going to want to play it safe because we don't want to put people at risk, and having a whole bunch of people up in the same place in a small environment is not really a wise thing to do at this time. Thanks, Ella. I love that passion. You hold on to that and bring it with you when I see you next. Mamushi, I agree. The Eta Carina Nebula is one of the most beautiful objects in the night sky. And again, because it's so bright and big, anyone can see it. It's visible just naked eye from a good dark sky, but it would be visible pretty much anywhere except for the inner suburbs with a pair of binoculars or a small telescope. So if you have either of those things, go and download Stellarium, plug in the day and time that you're wanting to look, and find out where Eta Carina is in the sky, and then go out in the night sky and find it yourself with a pair of binoculars or a small telescope. I guarantee you won't be disappointed. Unless, of course, you're expecting it to look like this. Like this. There we go. Point the right direction. Yeah. This is what it looks like with a telescope after several minutes of exposure time. You won't see color, but you will see structure. Melissa says, thank you for sharing, Neil. We wish we lived a bit closer. Yeah, it's a bit tricky having us out on the edges of the suburbs, but that's because it's a good place for astronomy. That's when Monash University built it. They built it away from the city to get away from the light pollution. So our remoteness is partly one of our strengths. However, we have adopted the online streaming lifestyle with gusto here at MBO. We're doing our monthly live streams, and I'm doing these astrophotography live streams as often as I can. So even if you can't get to us, we try to get to you. And membership is still worthwhile. We have a fantastic newsletter. We have weekly members' nights, many of which have amazing guest speakers. Up until COVID, they were all in person, but since then we've been doing it live online, so members can come along virtually, and we are intending to continue that even when we return to in-person members' nights. So if you can't come but still want to participate, membership is still worthwhile for that reason. Okay, so let's go back to Ida Karina. We have now got how long? 12 minutes. We'll stop it at that. We'll save that and clear it. But we're going to do one more target just quickly before we finish up at about midnight. Do we have any requests from people for objects that we could have a look at? First person to pick an object that I think would be a good target, and we'll go there. There's always a little bit of lag and delay in a live stream and from people commenting. So let's see what comes up first. Pleiades. I think that might be behind my local horizon, but let's just see. Actually, I'll go to the sky view. That'll tell me. Yes, the Pleiades are down. Let me go to my other monitor to show you. The Pleiades are down here, unfortunately. That's well and truly behind my house. So unfortunately, no. We're looking for something in the Milky Way between Orion and the Southern Cross. So anywhere through here is probably our best bet. Sirius and the Pup, possibly. Tarantula, that might be good. Saturn's ring. Saturn has set. Let's just see first of all. Oh, I did mention the jewel box, didn't I? Let's just see first of all if the tarantula is up. And it is there. That's the tarantula there. Or maybe I'll go a little bit past. All right, we'll do the jewel box first, and then we'll go to the tarantula because they're both bright enough that they won't take too long to get an image. So, Stellarium, search. All right, so we will do the jewel box now. We'll spend about 5 minutes there because it's a star cluster. It doesn't need long exposures like nebulae do. And then we'll go to the Tarantula Nebula for a short while because that's another bright one that doesn't need too long in order to see. All right, so go back to our finding preset. There it is. Other way. It's always the other way, isn't it? These telescopes, depending on which side of the mount that they're on, the directions that they move kind of flip. So it's a bit of pot luck. All right, now for this one, I'm actually going to load the imaging preset, but I'm going to change it. I'm going to go down to 2 seconds because stars are bright and they will very quickly overwhelm the sensor and clip. So that will mean that it won't show the color as well, but we'll still do a live stack. And already we've got some good stuff showing up. No, that's not what I wanted. Go away. There we go. And we need to turn back on our guiding. 0.93, that's not too bad. I prefer it to be below 0.7, but that's hard to get. Okay, there we go. Hang on, do that. Stop it, pick a star, guide. Back to imaging. We'll clear it just because it was moving around while I was doing that. All right, so that's 2 seconds already. Let's zoom in to 100% on that one. And those settings are no good for that. It's way too high contrast. So I'm going to reset the histogram and go for color balance. Not quite right. Also not right. What about resetting it? No, it's too red. That'll do. All right, let's brighten the mids up a little bit. There we go. That's starting to look good. Lovely. All right, let's just give it a minute to get a little bit of data on it. But you can see here I mean, obviously, the reason why it's called the jewel box, it is absolutely a jewel. Oh, I just realized I've left my other screen on again, so you're seeing it smaller. There we go. So yeah, when you look at this through a telescope, you can distinctly see the A-frame shape. So you've got, it's upside down in this view, but the V shape here and this sort of crossbar here, it looks like a capital letter A. And this star in the middle here, it's very clearly a different color. It's very orange compared to the rest, which look kind of whitish, maybe a bit yellow. This cluster here, they're all part of the same cluster, except for that red star. That is just in the foreground. It just happens to line up. I mean, if you look around here, you can see there aren't many stars as bright as that one. So we just got lucky that this beautiful red star happened to be lined up with all the other gorgeous stars in this cluster. So yeah, we've only got less than 100 seconds worth of exposure so far, but it's already a beautiful shot because you don't need a lot of information, a lot of data from stars because they're bright. Nebulae are faint. So there we go. That's the jewel box. We'll let it get to a minute or to 120 seconds, which is 2 minutes, and then we will save it and move on to the tarantula before we finish up. There we go. Save it at 120. All right. Now we will go to our finding preset and look up tarantula. Okay, current objects, slew, and let's watch the telescope go. Looks like it's going all the way around the other side of the sky. It's got to flip upside down. We had a request for Omega Centauri, but it's getting late and I'm getting tired. So let's hold that one off for the next time. All right, let's see if we have a tarantula in sight. Okay, maybe not. It might be there. Let me just move things over to put this in the center a little bit, and then we'll do some longer exposures and see if that comes up. Rose says she's getting ready to do a screenshot. You can, but I'm going to tweak all these images and process them a little further and then post them to the NBO Facebook page. So getting a screenshot is great because it's in the moment and you can sort of see everything else that's going on around it at the same time. But if you want to see the images at their best, and that's just these images, not the objects, because I can do better with longer exposure times, then watch the NBO Facebook page and I'll be posting to there in the next couple of days when I've had a chance to process these. All right. I don't know if this is the right spot, but I will get a quick shot and see if that is correct. All right, 5 seconds. We've still got the histogram on there. So I keep forgetting to do that. Oh, hello again, Aki. Okay, that's a bit better. No, that is not the Tarantula Nebula, but it is in the area. Okay, I'm going to go back to the finding preset. I mean, that's a nice little area to explore at some point. But I want to find the tarantula specifically. Now, because it's on the other side of the sky, it means that when it moved across, the telescope moved across trying to find it, its position was off by a bigger margin. So that's why we didn't go straight to it like we did the other objects. Is it out this way? Yes, there it is. Like I said, this one's bright. All right, it looks small, but when we get some exposure time on this, you'll see what I'm talking about. All right. Go back to the live stack. Clear, reset. All right, let's see what comes in the first 15 seconds. Ah, lovely. All right, so try an auto stretch. Okay, sorry, that's the auto stretch. That's the wrong color, but we'll try and stretch that as well. There we go. Ah, yes, we've also lost the guiding. Stop that. Restart. Pick a star and no, that's way too bright. And guide. All right, now I'll reset this again. Although it's already starting to come out looking good, which is great. Okay, Grace is asking about the location of Eta Carina. So let me just quickly pull up Stellarium. So if we look, this is south here, okay? And to the lower left of south, we have the pointers and the Southern Cross. The way I usually say to find Eta Carina is if you imagine the line between the Southern Cross, the one that goes up and down here, if you imagine that as a mirror, so the pointers will be flipped over the other side of the Southern Cross. So not up here, because that would be a direct flip, but mirrored, it's over here. So that is about where the Eta Carina Nebula is. So at the moment, it's directly above the Southern Cross. But as the night continues, the Southern Cross will continue to rise and move around to the clockwise direction, as will Eta Carina. It will continue to move around to the right. So you want to find the Southern Cross, and it is on the opposite side, mirror flipped from the Southern Cross. And from dark skies, you should be able to see this whole area as a fuzzy, faint fuzzy patch. The brightest part of that patch will be the Eta Carina Nebula. So point your binoculars or your telescope towards that, and you'll be able to find it. All right, let's go back to our imaging. And yeah, it doesn't take long for this to come out. So we've only got 90 seconds so far. Let's tweak those stretch settings a little bit. And we've got a bit too much green. Bit of pink back in there. Drop off some of the blue. Yeah, I reckon about there is pretty good. All right, let's go in a bit closer on that. It's still very grainy at the moment because we've only just started, but at 50% size. Yeah, very noisy right now, but look at that beautiful shape. You've got these lobes coming out here. And you can sort of see why it's called a tarantula, where it's got this sort of body in the middle and these legs sort of coming off in different directions. Yes, if you wanted to find the Large Magellanic Cloud, if you wanted to find the Tarantula Nebula, it is in the Large Magellanic Cloud. You won't be able to see it naked eye unless you've got very good eyes and a very dark sky, but a pair of binoculars will certainly reveal it. It would look more like, well, it won't look that big for a pair of binoculars. So you'll see that it'll look like a very small grey cauliflower in space, I suppose you could say, or maybe a tarantula. But we'll go back to 50% zoom and watch that for a little while. We'll get a little bit of data on that before we finish up. So I'll take this opportunity to answer any last minute questions. So if you've got any last questions before we finish the night, pop them in the chat, perhaps just one each. I won't probably be able to answer them all. Grace asks, why is it? I'm assuming Grace means Itacrina, not in Skyview. I don't use Skyview, so I'm afraid I couldn't answer that for you. I recommend Stellarium. It's free on the desktop and it's a few dollars on mobile. And I think most astronomers would recommend Stellarium as the best user-friendly, comprehensive astronomy finding software or planetarium software. I can't help you with Skyview, though. I'm sorry. Helen Smith, lovely. I like that. I don't hate spiders. They're cute little fuzzy things that have their place in the home, eating mosquitoes and stuff. But you are right. This is much more beautiful than most spiders. Ella asks if Stellarium is on Mac. Yes, it is. It is also, I believe, on Linux. So it is a multi-platform. So Macintosh, PC, Linux, Android, and iOS. Very comprehensive. Good question from Arona. Do nebulae always look exactly the same each time? And she added, or they added, or do they change a bit? The vast majority of nebulae look exactly the same from year to year. However, nebulae which are very close to Earth, which means that they are probably very small, but being small means that changes you see on them will be happening in their scale. So the Tarantula Nebula is absolutely humongous. It's a couple of 100 light years across. If you want to see any change in there, if even a light year of movement is going to be less than 1% of its size, right? But if you've got an object that's, say, 10 light years across, a light year of movement is going to be 10% of its size, okay? So if you want to see movement, you want to look for smaller objects that are closer to us. They have to be close to us because if they're small and they're far away, you won't see them. So that's sort of a minimum requirement. And then only certain nebulae actually move quickly. They're usually things like the leftovers of explosions from supernovae or other dramatic events like that. A good example of one like that is called the Crab Nebula. And while an amateur, even an astrophotographer like myself, looking at the Crab Nebula year after year, probably won't see much change. If you have high quality equipment amateur equipment, yes, but expensive, high quality, high resolution amateur equipment, and you take a photograph every year for 10 years, you will actually see movement. And in fact, I can find an animated GIF of that because it was an amazing sequence done by an astronomer just like that. So give me a moment. So let me load that up. This is just spectacular. It absolutely blew my mind when I saw this. What you're seeing here is a series of images taken by Detlef Hartmann over 10 years. There's only about 10 frames in this that are actual data. The intermediate frames to make it animate smoothly were interpolated. That is, a computer analyzed the motion of the pixels between the frames, and when they jump a distance, it made up pixels in between that to make the motion look smooth. However, this was done by an amateur with high quality equipment over a long period of time, 10 years or so. And you can see not only is the nebula expanding, but you can actually see like a twister maelstrom in here from this star here. That is a white dwarf. It is the core of the star that exploded in a supernova to make this nebula. That explosion only happened a few hundred years ago. So what we're looking at here is a relatively small object that is relatively close. The spinning here is the rotation of the star inside the nebulosity and its magnetic field dragging the charged particles in that gas around with it. There's a big lag behind because obviously the star is spinning much, much faster than the nebulosity, but it gets dragged behind it in the magnetic field because a lot of those particles are charged. Also, you can see coming out sort of here, a bit of a jet pushing out. You can see a little bit of the same coming up here. A lot of these rotating stars, when they, dead stars like this, white dwarfs or neutron stars, they push out material from their poles because of that strong magnetic field. So what you're seeing here is a live dynamic demonstration of the rotation of a star's magnetic field inside an expanding nebula that it created upon its death. That, to me, is one of the greatest astronomical image sequences ever taken. Just completely blew my mind. And I hope you all agree. I haven't been watching the comments for that bit because I was in a different web browser page. Rose, that is perfect. It does look like a beating heart. Stuart, I can't believe I surprised you. Have you not seen that before? It is incredible, isn't it? Let's see. One more question. I'll take this one. Actually, I just checked there's a message in private chat. Okay, Petra says she has to go. Thank you so much, Petra, for all your help tonight. You've been wonderful. You've been amazing help with the technology behind the scenes. If everyone would like to just say thank you to Petra in the chat, I'm sure she would appreciate that. She's heading off now, and I'll be heading off shortly as well. But I'll answer one more question, and then we'll have a closer look at what we've got with Tarantula. But Terry asks, how many nebula could you see in one night? Again, that's a how long is a piece of string question, but there is a group of objects called the Messier catalog, and there are a bunch of bright nebulae and star clusters and other objects like that that an astronomer Charles Messier collated because he got them mixed up with comets. He was looking for comets, and he didn't want to be misidentifying these objects as comets. Well, that list is, because it was made in the early days of astronomy, it just happens to be a very good list of very bright, mostly objects that are quite interesting. And there's 110 of them. All of them are visible from the Northern Hemisphere. And there is a particular time of the year when, as the sun sets, you can see one of the objects. And then throughout the night, as the Earth rotates under the sky, by the time it gets to the morning, you can just start to see rising the 100th object. So I think it might even be the 110th, but there is a challenge in the United States and other Northern Hemisphere countries to try and see every Messier object in one night. It's called the Messier Marathon. A number of people have succeeded in doing it. So it doesn't directly answer your question about how many nebulae you could see, because there are more than nebulae in the Messier catalog, but the right determined person could see dozens of nebulae and other deep sky objects in a single night. But you would need to know exactly where you're going so that you can jump from one to the other in quick succession without having to hunt for them. Me personally, I probably would never look at more than half a dozen in a night, partly because I wouldn't go the whole night looking at different objects, and also partly because I like to spend a little bit of time looking at each one. It's a bit easier for me because I can just type the object into my computer and it will pan to it. If you're doing it visually or with star charts, that would be a bit harder, a bit slower. But it's an interesting challenge for those who wish to try in the Northern Hemisphere to go for the Messier Marathon. All right. Where was your comment? There you go. Just turn that off again. And Stuart is replying to my comment before if he hadn't seen it before. Nope, he hasn't. Just like several quadrillion tons of dust and gas, I'm blown away. That's a great way to put it, Stuart, and I couldn't agree more. All right, we'll have one last look at the Tarantula Nebula, and then we will call it a night. So we are slowly reducing that background noise a little bit. I think some of that is actually sensor noise, which doesn't change from frame to frame, and so it's not going to go away with stacking. But I can deal with it in other ways. But this has turned out to be a lovely object. I mean, look at the different levels there. Before, when we were looking, we could see these rough shapes, but now when we look at it, I'll go closer. There'll be a lot of grain, but a lot of noise. When you look, you can see there's sort of rippling throughout these structures. They're not just lobes, they're mottled. They've got lots of different structure and sub-detail in them. I really need to do something about that grain and that noise for the next live stream because it's very distracting and I think I can get rid of it. But that's still a great image, a great demonstration of what you can see with this object. And look, there's a really tight but huge star cluster in this object. One thing I haven't mentioned about this nebulae is it's actually in another galaxy. I said before it's in the Large Magellanic Cloud, but I didn't say what that was. The Large Magellanic Cloud is a dwarf galaxy that orbits the Milky Way. It's about 160,000 light years away, a light year being about 10 trillion kilometers. And yet this galaxy is so big and so bright, we can see it with a pair of binoculars in our backyard from another galaxy. This thing is huge. We started the night looking at the Orion Nebula. That is about 1,600 light years away. This is 160,000 light years away. If this nebula was as close as the Orion Nebula, it would be as bright as the full moon and would fill up a quarter of the sky. How cool is that? So this is another amazing, remarkable object. The universe is just so full of things that will blow your mind. And that's probably a good place to leave it for tonight. So I hope you've all enjoyed yourselves in this little impromptu live astrophotography session. It's been a great night. We've had good, clear skies, no technical problems. Things have all worked as they should, and we've been able to hop around quite a few interesting objects. It's great fun doing this with you all. I really appreciate the feedback and comments that you leave. This stream, like all others, will be automatically saved and uploaded to the Facebook group when it's done. It's also on YouTube, so you'll be able to go back there and find it if you want to view it, say, on your smart TV or share it with others who don't have Facebook. I don't know when I'll do this again next. It's hard to predict when I'll be available or when the weather is good, but hopefully a couple more times during summer so we can look at some of the other objects in the summer night sky. Happy New Year to everyone. Even though we are doing well against the battle of the virus at the moment, please keep doing your best. Stay at home if you can. Wash your hands, wear a mask, avoid large groups, and do everything you can to keep us on top of things until we can get the vaccine out to everyone. Hopefully that will mean also that we'll soon be able to bring you all up to MBO once again. So take care, everyone. Stay safe. Good night. Keep watching the skies and have a good one.